Hey, it's the last video. Let's do this. Alright, so we're still in chapter 12. Today we're going to talk about Lewis structures. It's basically how are those atoms going to be bonded. Um, when we do Lewis structures, it's basically going to be a drawing. So if you're good at drawing, this you might find this fun. If you really suck at drawing, don't worry because we're not actually going to be drawing like people or clouds or anything like that. We're basically going to be drawing what a molecule looks like two-dimensionally. So let's give it a shot, and here we go. This is the definition of Lewis structures. It's basically a structure in which atomic symbols represent a nucleus. So like H, that'll represent the nucleus of hydrogen, and K will be the nucleus of potassium, and all the inner shell electrons. Dots and bonds are going to represent a valence electron. Now, we talked about valence electrons in the previous video, so if you haven't watched video 1 yet, part 1 for chapter 12, make sure you watch that before doing this one. Okay. There's also going to be this term for you called resonance structures. Basically, it's a condition occurring when one or more valid Lewis structures are possible. And that's actually a good thing for you guys because certain molecules can be drawn different ways. Like I could draw a molecule one way and it would be right. Then Aaron Lang could draw a molecule another way and it would still be right. So there might be more than one possible Lewis structure option, and I'll show you an example of that later on in this video. Okay, some bonding definitions for you guys. I know I went over these the last time, but I didn't really have a slide quite like this. I kind of just talked about it, but I want to pull it up one more time. A single bond is a bond where one pair of valence electrons is shared. One pair meaning 2 electrons total. Second one, double bond, is when 2 pairs are shared, which means 4 electrons total. And then a triple bond is when 3 pairs are shared, or 6 electrons total. Okay, so we're going to see things like single bond, double bond, and triple bond. Now, single bond is way more common than double bonds and triple bonds. Some compounds, though, will need triple bonds. It's not like every single one will, but there will be a couple that you're going to have to do these triple bonds for, but a majority of them will be single bonds. Okay, here's my tips. I'm going to go through all these tips, and I'm going to pull them up here. They're just advice. I mean, you don't have to follow them. They're not set in stone, but it's the best way I can show you how to do it. If you guys know, I never liked my high school chemistry teacher. I basically taught myself and I taught all my friends how to do it. And this is how I taught everybody. So, number 1 is you're going to count the total number of valence electrons that you have. So you basically look at what elements you have. You're going to count up the number of valence electrons that they all have combined, and you're just going to write it down. Number 2 says place the fewest atoms in the middle. So for example, if you have H2O, there's 2 hydrogens, there's 1 oxygen. When we draw these things, I'm going to put oxygen in the center because there's only one of those where I have 2 hydrogens. Well, next thing you're going to do is you're going to draw a bond line connecting all the things together. Number 3 is you're going to distribute extra electrons on the outside atoms first to fulfill that octet rule where they're all surrounded by 8. You're going to place any leftovers you have on the central atom so that it also has 8. Number 5 is like a break in case of emergency kind of tip. So if needed, you might have to redistribute electrons by making those double and triple bonds. Now the whole rest of this video, we're going to do some examples. I'm going to start with good old water. So water, I have first to count up how many valence electrons that I have. Well, if you guys look on your periodic table and you find hydrogen, you know that each hydrogen has one valence electron, right? And there's two of them in water. I have two H's. That gives me a grand total of two valence electrons, each one having one. Oxygen, there's only one oxygen in there. Each oxygen has six valence electrons. In this compound, I'm going to have a grand total of 8 valence electrons. The next tip I told you guys to do was lay out your basis of your drawing. And I told you to make sure that you put the one with the fewest number, in this case oxygen, in the center of your drawing, and put the remaining atom or atoms around it. So for example, I'm going to put oxygen in the center, and I'm going to write one hydrogen on the left, and I'm going to put one hydrogen on the right. Therefore, my oxygen is in the center, my two hydrogens are on the outside. Now I have to draw my connectors. I have to connect these together. And what I'm going to do is kind of have oxygen to be my center focal point and have these hydrogens branch off of it. So when I draw my connectors, I'm going to connect this hydrogen and oxygen together and this hydrogen and oxygen together. Okay? I've connected everything together so it's in one giant piece. Now, each one of those connector lines, each line that you draw, that is going to represent 2 valence electrons. Now I know I started with 8. Since I drew 2 connector lines, I've used up 4 of the 8 that I started with, which means that I have 4 valence electrons remaining. Now the next tip I told you was to draw dots around these outside ones to fulfill their octet. Well, hydrogen's a weird one. Hydrogen doesn't want 8 valence electrons. Hydrogen only wants 2 valence electrons. Now, this hydrogen right here has 2 valence electrons because it's sharing electrons with that O. And this hydrogen over here also has 2 valence electrons. It is sharing those 2 with the O. So I'm actually going to not add any extra dots around the H's. Now the next step that I'm going to do is I'm going to add the dots to the center atom. I have 4 more dots to go. I have to put these 4 dots around the O like we did with the Lewis dot diagrams. So I'll put 2 on this side and I'll put 2 down here. Last thing I'm going to do is check to make sure that my oxygen is okay. Oxygen has a grand total of 2, 4, because it's sharing here, 6, 8 valence electrons around it. So hydrogens are okay with their 2, and oxygen is happy with its 8. This right here is the Lewis structure for water. In reality, though, you wouldn't have those circles around it, so it would really look more like this. So I'll draw it one more time without the circles. That makes it a little bit cleaner. This would be my Lewis structure of water. Let's try another example. I have NF3. The first thing I'm going to do is I'm going to count up the total number of valence electrons that I have. Well, I have an N. N is 5 valence electrons. And I have F, but there is 3 of them in this formula. So I have 7 with this F, 7 with this F, and 7 with this last F for a grand total of 21. If I add this together, it gives me 26 valence electrons to play with. I'm going to decide which element is going to go in the center. I'm going to pick N because that's the fewest number in the formula. So I'm going to draw my N, and then I'm going to draw my F's all around it. So I can decide wherever I want to put my F's. I'll put maybe one F here. We'll go one F on the top, and then I'll put my third F over here. The next thing I'm going to do is I'm going to make my connectors. I have to connect them all together again, kind of like a tree. So this F is connected to the N now. This F here is connected to the N here. And then this N is connected to the F over here. Each line is represented by 2 valence electrons. So of my 26 I started with, I've used 2, 4, 6. That gives me a grand total of 20 remaining. The next step is add the dots around the outside ones to fulfill their octets. Now, unlike hydrogen, fluorine does want to be surrounded by 8 total valence electrons. Now, the fluorine right now only has 2 on it because it's sharing the 2 with the nitrogen there. So it needs 6 more dots. So I'm going to go 1, 2, 3, 4, 5, 6. That gives me a grand total of 2, 4, 6, 8 dots around that fluorine. 2 of the dots again being represented with those lines. Now I just used 6 additional dots. I have 14 left. Let's do the same thing to this fluorine because it also wants 6 dots. That gives me 8 left. This fluorine also needs 6. So now all my fluorines are taken care of. They are all surrounded by 8 valence electrons. Now the last thing I have to do is put all of my leftovers onto that central atom. Nitrogen right now only has 6 valence electrons on it. It needs 2 more to get up to 8. Luckily for me, I have 2 left to give it. So I'm going to put 1 dot here and 1 dot here. Right, Stephanie?
What?
Right?
Yeah.
2 dots. She says right. She knows her stuff. So I've used up, and you can feel free to count them if you want. If you remember, we had to use 26 total. I used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 total valence electrons, and I started with 26, and each element is surrounded by the 8 valence electrons that they want. Let's try another one. Let's try CCl4. If you want to try it on your own without my help, feel free to pause the video at any time. If you want to do it with me, I'm about to start in 3, 2, 1. So the first thing I'm going to do is I'm going to count up the total number of valence electrons that I have. Carbon is 4 valence electrons. I have 4 chlorines. Each chlorine is 7. So I have to do 7 times 4. That would be 28. If I add those together, it gives me 32 valence electrons to play with. I'm going to decide which one's going to go in the center. Well, it's going to be carbon. I'm going to draw my chlorines all around it. I'm going to connect the dots, or connect them all together with lines, sorry. So I'm connecting them with lines. Remember, each line represents 2. So far I've used 2, 4, 6, 8 of my 32 I started with. Gives me 24 more to play with. I'm going to start on any chlorine you want. You got to give it the dots that it still needs. Each chlorine wants to be surrounded by 8. Each chlorine only has 2 right now because they're sharing it with the carbon. So I'm going to go 1, 2, 3, 4, 5, 6 to that chlorine. Gives me 18 more. 2, 4, 6. Around this one. Oops, that should be 6, not 12. Whoops. I have 12 left. We go over to this one. 6 left. Those dots aren't good. Well, there's 6 dots around this chlorine. I'm sorry, it's not very pretty, but I just added 6 more dots like I did to all the other chlorines. So I'm out of valence electrons. I have no more valence electrons to use. But let me check and make sure everything is okay. I have 8 electrons around this Cl. I have 8 electrons around this Cl. I have 8 electrons around this Cl and 8 electrons around this Cl. The carbon, if I look at the carbon, I have 2, 4, 6, 8. Because remember, they're sharing them. They're equally sharing them. And I have 2, 4, 6, 8. That's already surrounded by 8. It does not need any extra dots, and that's good because I don't have any extra dots to give it. All right, I think I have a few more. Let's try SO2. I'm going to count up how many valence electrons. S, that's 6. 2 O's. Each one is 6. That gives me a total of 12. Add that together, 18. Pick which one to go in the center. Hopefully you know by now. Pick the one that has the fewest number. Put the other ones around it. Maker connection. I've used up 4 of my 18. Gives me 14 left. I'm going to take care of each oxygen first. I just used 6 more dots. Means I have 8 left. Just use 6 more. Now I have 2 left. I'm going to give it to the center atom. Now I'm going to look to make sure everything looks okay. This oxygen here has 8 around it. 2, 4, 6, 8. This oxygen, 2, 4, 6, 8. Sulfur, 2, 4, 6. One's 8 and it only has 6. So what is it going to do? Well, it's basically going to beg and plead that one of the oxygens decides to share 2 of these dots with it. 2 of these dots can be turned into another line. Okay, that's what's going to happen. So these 2 dots turn into another line. So they're technically gone because they got turned into another line. But this oxygen still has 2, 4, 6, 8 electrons around it. This oxygen, 2, 4, 6, 8 around it. And sulfur now has 2, 4, 6, 8 around it. I manipulated the system by forcing electrons to turn into bonding, sharing electrons. Okay? And I know you might be thinking, well, why didn't I pick this oxygen over here? Well, I was talking to you about that earlier. I can for sure do that. If I draw it again and I put the double bond on this side instead of on the other side, you can totally do that. They're the same exact thing. It's those resonance structures that give you multiple options to choose from, where you could pick the left oxygen for the double bond to occur, or the right oxygen for the double bond to occur. And remember, this is called a double bond because there's 2 lines. This is called a single bond. Let's try these ones. Actually, yeah, let's try these ones. Let's go for it. I'm going to add up my total number of valence electrons. N is 5. I have 3 oxygens. Each oxygen is 6. That gives me a grand total of 18. And you might be thinking, well, what is with this -1 here? That wasn't on the other ones. Well, when you see a -1, that actually means that you're adding one additional electron. It's very strange. I know you think negative. What does that mean? Why are you adding? Because it's negative? What? Well, electrons are negatively charged. When something is negative, it means it has extra electrons. So when you have a negative 1, that means you're going to add one additional. It's a really bad 1. You're going to add one additional. Okay, so now I'm going to take 5 plus 18 plus 1. That gives me a grand total of 24 valence electrons to use when I'm drawing this. I'm going to put N in the center. Put the 3 O's around it. Make my connections. Now, I have 24 valence electrons to use. Here's 2. Here's 4. Here's 6. Now I have 18 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That was my 18. I'm out of electrons. This oxygen right here has 8 around it. 2, 4, 6, 8. This oxygen, 2, 4, 6, 8. This oxygen, 2, 4, 6, 8. Nitrogen, because you also have to check the ones in the middle. 2, 4, 6. It's too short. Just like last time, it has to plead with one of these oxygens to have an extra bond, an extra double bond to occur. So what's going to happen is you can pick any one of the oxygens. It does not matter. But you're going to take 2 dots. I just picked this one. These 2 dots are going to become a second bond, giving me a double bond over here. So these are technically gone. And this would be my structure. Now, for those of you who feel like putting it on the top, it would look like that, right? And I'd have to add my dots all around it. Adding the dots. Aren't they pretty? Okay, and then I could also pick the one on the left. Okay, and then I would add the dots all around like that. So, you know, the person next to you might be drawing it like this right now. That's totally cool. You want to draw yours like this? That's cool too. Whatever way you want to draw it. All right, last one. Here we go. I have NH4. This time I have +1. When you have +1, it actually means you're going to take away an electron. I'm going to add up nitrogen. That's 5. 4 hydrogens. That's 4. This +1 means I'm actually going to be losing 1. If I add this up, 5 plus 4 plus a -1 gives me 8 total. Put the N in the center. Put those hydrogens all around it. I had 8 to play with. 2, 4, 6, 8. I used up the 8 electrons I had. Each hydrogen only wants 2, so they're fine. Nitrogen wants 8. 2, 4, 6, and 8. Okay? I'm going to just do one more over here in this little corner. I'm going to do N2. N2 is a really good one to do. 2 N's. That gives me a total of 10 valence electrons. Now in this case, because I only have N2, there won't be any central atom. I'm just going to put an N next to an N, and I'm going to connect them together just like that. You can pick whichever N you want to fill first. Now I had 10 to play with. I've used 2 so far. I have 8 more. 1, 2, 3, 4, 5, 6. Now this nitrogen is good. I have 2 more dots to give. Remember, I had 10 to use, and I've only used 2, 4, 6, 8. So I'm going to go 2 dots over here. Now if I look, This N on the left has 8 around it. It's happy. This N on the right, though, only has 4 on it. So what do I have to do? Well, I have to share some electrons. So let's take 2 electrons off. I took the ones on the bottom. Now if I look, 2, 4, 6, 8 for the one on the left, so it's still good. The one on the right, 2, 4, 6, it's still not happy. What has to happen is another pair of electrons has to be shared. This is referred to as a triple bond. When you have 3 lines connecting stuff, that gives you a triple bond. Triple bonds are pretty rare. If you notice, none of the other ones before this had it. So try to avoid triple bonds at all costs. They will not pop up very often, okay? Try to stick with single bonds. If you have to, do a double bond. And then if you really, really, really have to, use that triple bond, okay? So that is it for part 2. Hopefully these examples helped you with the second homework packet. That's it. After that, you can feel free to work on your study guide. Don't forget you get a double-sided note card to use on the exam. And then the study guide is due on the day of your exam, whatever day it might be. I hope you guys have a great summer. I really appreciated teaching you guys this year. You're one of the best classes I've ever had. And yeah, bye.